The topic of this video is using patterns to solve exponential growth and decay problems. Many natural phenomena have been found to follow the exponential law that adding time results in a multiplying or dividing of the amount or number. There are two ways to solve exponential law problems. There is the short way, which can't always be used, and the long way, which can always be used. We will call the short way using patterns, and we will call the long way using the exponential law equation. We begin by looking at patterns. Method 1, the short way, using patterns. The following tables represent exponential decay, shown in Table 1, and exponential growth, shown in Table 2, which is a bit further down the screen. We begin by looking at Table 1, an example of exponential decay. Our first column lists an amount of time, and our second column lists an amount of medicine in a patient's bloodstream. At 0 hours, the starting time, there are 243 milligrams of medicine in the patient's blood. Perhaps that was given by injection. 1 hour later, the amount of medicine in the blood is now down to 81 milligrams. 2 hours from the initial injection, it's now down to 27 milligrams. 3 hours, 9 milligrams, 4 hours, 3 milligrams, 5 hours, 1 milligram. There is a pattern here. For Table 1, note that for each row, 1 hour is added. This is the value of A, the adder. In addition, for each new row, the amount of medicine is divided by 3. This is the value of D, the divider. 0 plus the adder of 1 makes 1. 1 plus the adder of 1 makes 2. 2 plus the adder of 1 makes 3, and so on. 243 divided by the divider of 3 gives 81. 81 divided by the divider of 3 makes 27. 27 divided by 3 is 9. 9 divided by 3 is 3, and so on. This is an example of a pattern that can be used to predict exponential decay. Let's move on to Table 2. Table 2, an example of exponential growth. In this table, we see that the first column is an amount of time, this time measured in days, and the second column is the number of tadpoles in a small pond. All right, at 0 days, which is the starting time, we count and measure that there are 8 tadpoles. When we come back 3 days later, we find that there are now 12 tadpoles. Another 3 days later, which is 6 days after the original measurement, we now have 18 tadpoles. And at 9 days, we have 27 tadpoles. There is a pattern here. For Table 2, note that for each new row, 3 days is added. This is the value of A, the adder. In addition, for each new row, the number of tadpoles is multiplied by 1.5. This is the value of M, the multiplier. 0 plus the adder of 3 makes 3. 3 plus the adder of 3 makes 6. 6 plus the adder of 3 makes 9, and so on. 8 times the multiplier 1.5 equals 12. 12 times the multiplier 1.5 equals 18. 18 times the multiplier 1.5 equals 27. Notice that when we are dealing with decay, we have an adder and a divider because the amount is getting smaller. But when we are dealing with growth, we have a multiplier because the amount is getting larger.